Hello, everybody, and welcome to our next installment of the Long Coffee Break. My name is Travis Cowan with Long Building Technologies. Today, we have Steve Clark with Seeley International here with us. Steve will be talking about cooling below the wet bulb regarding, looking into especially energy efficiency and electrification issues. Steve, thank you so much for joining us. It's a true pleasure. The floor is yours, sir.
Okay, thanks, Travis. Today I'm going to talk about our Climate Wizard units and energy savings by cooling below the wet bulb with our indirect evaporative cooling units. So I'm first going to start out, I know it's kind of early in the morning to start out with psychrometrics, but we're going to dive right into this. So if we look at a psychrometric chart using the Denver design conditions of 9560, we first look at direct evaporative cooling or swamp coolers. And we start at this 9560, we follow the wet bulb line up to about 65 degrees, 80% relative humidity. This is fine for warehouse spaces. A lot of homes in the desert Southwest have swamp coolers. And Seeley International actually makes, this is basically our cash cow for the business. So we know these direct evaporative cooling units very well. We also know our indirect evaporative coolers called the Climate Wizard units, which start out the same 9560 design conditions, do sensible cooling down here to about 59 degrees. Notice this is 1 degree below the wet bulb. And so these are our, basically our most basic indirect evaporative coolers. Then we have, on some of our units, we have what we call a super cool option, where we can follow the wet bulb line up. In this case, we're going down to about 48 degrees with that unit. These and these super cool units, this is a direct evaporative pad, which can be cycled on and off. So you can have indirect evaporative cooling down to this point, cycle that on and off as necessary. If we look at our products that we make, we have three basic products. We have the CW-H15 and the CW-80 units. These are both for commercial and industrial spaces. The CW-H15 we make here in Denver, and that's rated about 2,300 CFM. Then we make a larger unit called a CW-80. It's 13,500 CFM by itself. And then we can put two of those together for 27,000 CFM. And then coming back here to, and we also make a residential unit called a CW3. It's based on the same technology of these two. I'm not going to really cover that, but that's designed for residential light commercial applications. We just started selling this in the US about 2 years ago. The CW-80 and the CW3 are both made in Australia, where our parent company is. If we look at the heat, part of our cooling technology, the important part, we call a heat exchanger, or we call it our core. This consists of a heat exchanger of plastic sheets that we have alternating wet and dry sheets in this heat exchanger. Basically what we do is we take the hot outdoor air, ambient air, we run it through the dry sheets, and where it's cooled down indirectly by water that we put in the top. A portion of that cooled down, dry cooled air goes back through the wet sheets, is combined with water that comes down from the top, and this is exhausted out of the unit is this warm, moist air that's commonly known as scavenger air. And of the air that's coming in, about 55% of it is the conditioned air that goes to the space. About 45% of it is the warm, moist air. If we look at a picture of our heat exchanger core, which is shown here, this unit is about 24 inches wide, about 24 inches deep, 32 inches high, about 800 CFM. of conditioned air coming out. So we have the hot outdoor air coming in through, and this air goes through the dry sheets. And then we have water in this section that goes through the wet sheets. And then we have our exhaust air coming up here through the heat exchanger that's exhausted to atmosphere. And we put, these modules are made in Australia, and then we put those in our units that are made here in Denver, as well as Australia puts the units in the CW80 units in that are made over there. If we look at a close-up view of our wet and dry channels, we have this plastic with convolutions on it to create highly turbulent airflow. And then we have wet channels, which is the same sheet as the dry channel, but it has a special material in here that wicks up the moisture and allows good heat transfer from the dry channel into the wet channel. So this is a proprietary patented heat exchanger that allows us, again, to go below the wet bulb temperatures. Here's another close-up view with it in the unit. So now we'll let's take a look at typical performances in different types of climates. So this is looking at the supply air, for various types of climates: arid, temperate, continental. This one is pretty close to the Denver design conditions. And you can see the leaving air temperature. These are quite impressive of our different units: the CW H15, the H15 with a super cool, the CW80s. And then if we come down here and look at the pre-cooling capacity for these same climate zones, we look at the tonnage, notice the EERs. I mean, these are orders of magnitude above conventional DX cooling. And that's because, we have the efficiencies, we have very little, our units use very little energy since there are no compressors in the units. So if we look at a cross section of our units that are made in Denver, we have a fan out here, an outdoor air fan, pulls the air through filters, Mervate filters. This fan is made by EBM. So it's a backward incline fan that's directly coupled to an electrically commutated motor, an EC motor, high efficiency, and that pressurizes this plenum, whereby the hot air goes through the dry channels, clear out through the unit, and is cooled down. And then we have a portion of this air is directed back through the heat exchanger and exhausted out to the outside. Then we have some what we call water manifolds that deliver the water down through the wet sheets. That water comes into a sump where we have a pump that continuously recirculates this water. We also have a conductivity probe in the sump that will automatically blow down the sump, the water reservoir, to keep the minerals within a certain specification. That's how we get rid of our minerals. We also have a chlorinator in here. So we're generating free chlorine in this sump electronically, so to keep any bacteria at bay. And of course, in this case, the air is not in direct contact with the water. But in addition to that, it has some chlorine in it, a little bit of residual chlorine. Our supercool units have this direct evaporative pad. So the indirect, the air cooled indirectly goes into this direct evaporative pad, or even lower temperatures. And in cases where you need a little bit of humidity to the space, you can cycle this on and off. This is on a separate pump. I should also mention that these fans are variable speed. So we can control them at a variety of speeds and airflows. In addition, we can turn the pumps off, and this unit can be a ventilation unit for outdoor air economizing. And then the supply air comes in to the space here. So this is what we call our blow-through design. If we look at our large units that are made in Australia, our CW80 units, the 13,500 CFM of delivered supply air to the space, these units are really an industrial bulletproof unit they're about the size of a shipping container. You can see the person standing there, a silhouette of a person, to give you a sense of the size of the unit. It has 16 of these cores, these heat exchangers. The outdoor air enters into this stainless steel louver. Behind that is a MERV 8 filter. We can go up to a MERV 13 filter. So we have the outdoor air coming in through all these inlets. And then on the opposite side, there's another 8 heat exchangers for a total of 16. And then we have our exhaust fans on the top. This is our H15 units are a blow-through design. This is a draw-through design. So we have 2 fans, backward inclined fans that are pulling the air through the dry channels. And then we have the exhaust fans, also a backward incline direct drive fan pulling the exhaust air through the wet channels. This entire unit, the outside is made out of stainless steel. It's on a galvanized steel frame. And then we have a electrical control panel, a plumbing panel back here, and the water and drain connections. The biggest unit we make is what we call a CW80T twin for 27,000 CFM. And that's basically 2 CW80s connected together with a top discharge. Just looking at a couple case examples, this is a very successful project that was done, probably 5 or 6 years ago on a automobile dealership called the Sullivan Auto Group. It's a large Toyota and Chevy dealership in Roseville, California, outside of Sacramento. They did about a $5.7 million energy efficient retrofit project on 3 dealerships using 51 CWH15 units that are made here in Denver, total of about 118,000 CFM. This picture on the left shows the units mounted on the roof. They used a variety of energy savings techniques besides our units, which you can see are ducted into space. They put a cool roof, a white roof on to reflect that solar radiation. They use skylights on the roof for the natural lighting to cut down their lighting power used. And then you can see solar panels on the roof. So let's look at the results of this energy retrofit. This was done by using, of course, a cool roof, skylights, power conditioners, and interior and exterior LED lights in 51 of our CWH15 units. The site, in addition to that, they had about 2,300 solar panels that generated about 1 million kWh. The energy usage before the retrofit was about 3.15 million kWh. Energy usage afterwards was 400,000 kWh. This is an 87% net site energy reduction. And our units contributed about 24% of the energy savings for all these methods up here. Saved about 170 million metric tons of CO2, or the removal of about 400 cars. Looking at a project in our backyard is the CW80S unit that was used on Regis Jesuit High School Gymnasium, where they had this gymnasium only had a heating and ventilation unit. This is the last building on the Regis campus, high school campus, to be air conditioned. They used a single CW80S unit installed in July of 2019. Measuring the EER, measured the EER on a hot day, we got 58. And that's right in line with the tables we talked about earlier, our performance tables. if we look at that on the psychrometric chart, this is how it plots out. So we have a 95-62. We're doing sensible cooling. We're 2 degrees below the wet bulb. And this is based on actual site conditions, which typically are better than what we calculate in our spreadsheets. And then that unit had a direct evaporative pad that adds, we wanted a little more cushion for this gymnasium. And quite frankly, 60-degree air was plenty cold for their gymnasium. So when, to my knowledge, they haven't even turned this on. They could turn it on if they want a little bit of moisture for their gym floor and lower temperatures. So they could do that. That's all I had for today. And we'll turn it back over to Travis. If you have any questions, you can contact me or Travis. So it's all yours, Travis.
If anybody has any questions about Seeley International, please contact your long sales engineer. We'll be happy to help you. And don't forget to join us next week. Matt Bilsmo will be talking about what's new in the world of EC fan arrays with QPAC fans. Thank you all very much. Have a great week.